So we're going to talk about solving equations using logarithms. Okay, and so when we look at a logarithm equation, that means we have a log in it, and we're basically going to switch the log to an exponential in order to solve the problem. Okay, so here's an example. We have log base x 8 over 27 is equal to 3, and we're solving for x. So basically we want to switch this to an exponential, which we just got done doing. So x raised to 3 equals 8 over 27, right? The 3, the answer, and what we're taking the log of switch places. The base stays the same. So x raised to 3 equals 8 over 27. And so now we can go ahead and solve this. We can get rid of the cube by cube rooting both sides. And when I cube root this side to the right, that means I'm taking the cube root of 8 over the cube root of 27. Cube root of 8 is 2, and the cube root of 27 is 3. So my answer is 2/3, and you can go put that right back in, and you can put that, well, haven't taught you yet how to put it in your calculator, but that is correct. You can take it right here. 2/3, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. So that's a little bit of a check, not too much. Okay, so you can go ahead and try this one on your own, and then I'll come back and do it. Okay, so take 4, switch this log to an exponential, so 4 raised to the 5/2 is equal to x. Alright, so here we could do that on a calculator. Type 4, you could hit this button on my calculators, or if you have a TI 30 or TI 31, something like this, you hit this hat button and you type 5 divided by 2 parentheses, and then if you hit this button on my calculators, you can type 5, ooh, that looks 5 divided by 2. Okay, on this one, and there is a way to do it without a calculator, show that, and then just do 5 divided by 2. Okay, so without a calculator, how we can do this is, remember, we can rewrite fraction exponents as roots. So this is 4 with the root, and then the denominator is the type of root, and the numerator is the power. And I probably don't want to put the 5 right here because I don't know what 4 to the 5th is. So if I put 5 on the outside, I do know what the square root of 4 is. That is 2. And then I'm raising that to the 5th, and so 2 times itself 5 times is 32. So x is equal to 32. And then we can go ahead and plug that back in, and really we're looking at just the principal square root. It could be plus or minus here, but we'll just look at the positive one. So 32, we can plug that back in, and you can type that in a calculator and you see you get 32 on there. Okay, another one. Okay, so this is log base of 49 of the cube root of 7 is equal to x. So we want to rewrite this. You can pause it if you're good. Here we go. So 49 raised to what is cube root of 7? Okay, so here it's a little, we just need to rewrite at the same base. So this is what we got done doing exponentials, right? We want to write the same base. So right now I have a 7 underneath here. Can I rewrite 49 as a 7? And then I need to rewrite this cube root as an exponent, right? So 49, I can rewrite that as 7 squared. Now 49 is being raised to x, so that means 7 squared is being raised to x. And I can rewrite my base 7 here. How can I rewrite cube root? Oh, cube root is to the 1/3, right? Now I have the same base, 7. Now what do I do when I raise powers to powers? I multiply, so 7 to the 2x equals 7 to the 1/3. Now that I have the same base, now I can set my exponents equal to each other. And now I can solve. Divide by 2, divide this by 2. Remember, dividing by 2 is like multiplying by 1/2. So I get 1/6. So x is equal to 1/6. Now I can go back through and check it. And so if we plug 1/6 back in, I plug it in here, and I could do that on a calculator. Take 49, take it to the 1/6, and then take the cube root of 7 and see if I get the same answer, which you do. So that's the answer for those. Let's go ahead and practice some problems. Page 423 and numbers 15, 27, and 29. So we'll go ahead and do those. Okay, so here's 15. Go ahead and you can try it yourself and then come back and listen. So x raised to the 5 equals 1 over 32. Now how I get a fraction, right, is, well, actually, all I can do, since x is in the base, it's a lot easier. When x is in the base, these problems are a lot easier, right? So if x was not in the base and was the exponent, then it's a little bit tougher, but this one's not too bad. So how do I get rid of a raising to the 5th power? Well, I 5th root it. So I want to 5th root both sides. So that means x is going to equal the 5th root of 1 over the 5th root of 32. So what that means, 5th root of 32 is meaning, or what you can do in another way, with fractions, right? So I could raise this side. I could raise this side to a power 1/5, because when I raise powers to powers, I multiply, and if I multiply by the reciprocal, I get 1. So that's x by itself. So that means I need to raise this exponent. What's the exponent currently on both of these? Is 1. So I'd be raising that to the 1/5, and so I would have 1/32 raised to the 1/5. And then I would distribute that to 1 and distribute that to 32, which is the same thing as this right here. Now, the 5th root of 1, or 1 to the 1/5, is asking to what times itself 5 times is 1? Well, that's 1. And then what times itself 5 times is 32? Well, that's 2. So 1/2 is your answer, and you could plug that back in. You can't plug that back in too much. You could plug it back into the exponential right here, 1/2. 1/2 times itself 5 times is 32. So that's the answer to 15. Now if we look at 27, we can switch this to an exponential. 4 raised to what? So this one's kind of going this way. 4 raised to what is the cube root of 16? So here x is an exponent, right? So I want to rewrite these, solve exponentials like we did in the last section, I believe, or the section before that. Was I got to raise powers to power, or I got to have the same base here, right? So I want to rewrite these same base. Well, I can rewrite 16 as a 4 by taking 4 and squaring it, and then this is being cube rooted, right? And so that equals 4 to the x. Now I have the same base, except for now I have this root. So I need to get rid of that root, and then I can come back. So I get 4 to the x equals, I can rewrite this as a fractional exponent, right? The type of root is in the denominator, so 3, and my power is the numerator. So now I have the same base, so now I can set my exponents equal to each other, and there's my answer, 2/3. And I can plug it back in and check that. 4 to the 2/3 is the cube root of 4 squared, which is the same thing as 16 cube rooted. Okay, last one, 29. So we can rewrite it. 9 to the 5/2 is equal to x. So this is asking, you could put this in a calculator to give you the answer, or you can rewrite it in terms of radicals, right? So the denominator says how many times you multiply a number to get to the base. So how many times, I'm going to multiply 2 times a number to get to the base. So what number times itself is 9, and then take that answer and raise it to the 5th, or the square root of 9 and then raise to the 5th. So what times itself 2 times is 9 is 3, and 3 to the 5th is whatever 81 times 3 is. So you have to get a calculator for that. Oops. There, sorry. Is 243. So that's your answer for x. Alright, so there you go. Those are solving logarithms. Okay, so you have to mostly switch them to exponential first and then solve it just like we solved all the other exponential problems from the last section.